包括在现场的学生，我们录影会给同学，所以我们总共人数将近90人，硕士班学生将近90人，那包含了一些师长阶段到学生哈。那我们今天很高兴，我们邀请到那个机械所工业技术所总部所长，来跟我们大家分享一下无人机的一些应用。那刚刚郑老师有稍微介绍过哈，那今天演讲完之后，每个同学回去都要写一个报告，报告是在1周3天到专门上去的。那个星期五的半夜前要交，不能抄袭50分。OK， 好I think that in the most of the section for the seminar, it will be sometimes in Chinese, sometimes in English. Anyway, for foreign student, you need to learn Mandarin. For Chinese student, you need to learn English. Okay? So it depends on our speakers, right? It may be mixed English, Mandarin together. Anyway, try to focus on what they show with us. Okay? And remember to give a report due on Friday midnight. Okay? Alright. So Professor Yang is the Deputy General Director from the Mechanical and Electronic System Lab from E3. E3 is one of the major research centers in Taiwan. Okay, it's located in Hsinchu area, in Zhudong. Okay, so I expect maybe even for foreign students, I expect some of you will be working with E3 in the future. OK， 我想你们未来有机会到工业去工作，那工业是一个很好的，我觉得说应该也算一个人才培训的一个点我想工业早期的任务也是在台湾培养这一些主要的中间研究人员，那很多机会你有机会，在工业待了几年之后，出去有个团队出去整一些新东西。所以未来我想你们还有很多机会跟工研院不止机械所、电子、化工这些都有机会接触那我们今天是不是再一个热烈掌声欢迎一下我们彭副所长？
尊敬的林校长还有王主任跟我们邓教授，还有在座王教授跟就是所有我们参与今天这个研讨的所有的各位的先进教授跟各位同学，大家午安So good afternoon everyone. I'm Wen Yang Pen from a research institute just nearby, about 20-25 kilometers from here. So, as our Professor Wang said that maybe in the coming future is a very good opportunity for everyone to go to our campus to have a look. I think that it will be very a good opportunity to learn something from the visit. Okay. So today is my honor to talk about the drone topic, and I would like to focus on the high payload multi-rotor drone. Try to explain the opportunities or the challenges, something like how to make this business become successful maybe in your country. Okay. So this is a very brief introduction of our institute. We have several core labs in our institute. As you can see from the slide, that we have electronic and optoelectronic system labs. Okay, and we also have the lab about the materials in the chemical industry. Okay, and I'm from this one. mechanical and electronic systems lab. Okay, so of course we have others core labs focus on the biomedical issue or green energy issue right now. Very hot topic issue. Okay, in our institute we have around 6,000 staff, and in the past we have several famous startups like TSMC or UNC. Maybe several of you have heard about that. So in my laboratory, we focus on the issue of smart living. Okay. In our institute, we have several missions or focus target for our research. So one of the important issues is to how to make a smart living technology for the coming future, to make everyone enjoy high quality living and to achieve your lifestyle. Okay. So there are several possible technologies to enable such kind of smart living happen. Like in our lab, we focus on the autonomous mobility, and not only autonomous vehicle, but also the drone. So drone is one of the autonomous vehicles, and in the field of the air. So typically, for the autonomous mobility issue, we usually study about the sensor fusion. You sense many kind of signals, much information from the circumstance of your autonomous vehicle, and then you have to utilize this information for the situation prediction and the decision making. So, and how we utilize this autonomous vehicle, especially, we focus on to enhance our mobility service and the logistics. Like in the Hsinchu city area right now, we have an experimental project to have our 3.5 ton our truck, 3.5 ton truck, autonomous truck, just have some experimental route in Hsinchu city. Okay, and also other topics like smart industry and services, how to enhance our business process, like the automation and optimization for the manufacturing process. And we also focus on some personalized applications, like we have some robot technology project to enhance the human-machine interactive devices, like the surface robot in the manufacturing line, that you have to satisfy the safety issue and to make it more convenient to use such kind of service robot. Okay, so this is the outline of my presentation today about the multi-rotor drone. Okay. So, am I allowed to take off my mask? Okay. Thank you. So I will give you some background about the drone industry development, and I would like to introduce some system integration development of the high payload multi-rotor utility drone, and talk something about hybrid fixed wing eVTOL or usually we said it's a kind of hybrid fuselage drone. So right now you maybe you get noticed that this term utility drone. Utility drone means such kind of drone is for the purpose of non-defense utilization, non-defense purpose. So you can for consumer, and also for commercial, industrial application. Okay, so I think that except the drone, you also heard about this term UAV, right? UAV means unmanned aerial vehicle. So there are several configuration types of UAV. In the past, the most early stage, most people or institute organizations, they focus on the fixed wing development, such as our government. About 25 or 30 years ago, we also started the fixed wing project for very long duration in the air for surveillance purpose. Okay, and also very similar. This is a shrinkage or smaller size of the human-driven helicopter. So we call it the single rotor UAV, right? As I know that there is a very experienced professor in this department, Professor Lin. In the past, he is a very good player or expert to play the helicopter, the remote control helicopter. So for drone purpose, you have to install the communication and also some sensing and also the control system, the autopilot control system, with regard to the remote control helicopter. Okay, so it becomes more autonomous, or you don't have to pay more attention about the attitude or the behavior of the helicopter in the air, so it becomes more easier for you to manipulate such kind of drone right now. And also, about 10 years ago, especially everyone noticed about this company, DJI, right? So DJI is a very successful case in this kind of drone, the multi-rotor. But if you have any idea of the DJI development history, in fact, the founder, Mr. Wang, for his thesis or for his hobby, for his beginning project, he is developing such kind of drone, the helicopter type. But he felt too difficult and not so easy to commercialize, so he gave up this kind of drone. So he turned into the multi-rotor type, and he adopted the digital control theory for the autopilot, and it becomes very stable, hovering in the air. So especially it is very useful for the photo-taking drone, right? I think that this is the most common type of drone, especially for the purpose of surveillance. And for surveillance, the most common way is you use the drone carry the camera to take some photos from the air. And so DJI is a very good player in the domain, and also right now in United States, there is a very strong competitor to DJI called Skydio. Also, with respect to DJI, Skydio has very differentiated core competence. It's about the AI function and also the autopilot mode under non-GPS situation. So right now, the United States government purchased thousands or 10,000s of drones from Skydio. That is because the Skydio drone can perform very well indoor and outdoor. Indoor without GPS and also outdoor, he has very good AI function. Can compete with the DJI, and the DJI right now is very rushed to catch up for the AI function. And also, I think that some people maybe have some video from the YouTube or other media that you notice that there is another kind of hybrid drone. That is a combination of the fixed wing and also the multi-rotor. There are very different type of configuration or morphology of this design. This is called the tail platform or the tail seater. The launch behavior or pattern is something like the space shuttle, right? You have your tail just stand on the ground, and you have your drone just have some takeoff to a certain distance height, and then you have the transition of your attitude to the cruise mode. So the transition include the 90-degree angle tiered. So this is one of the typical configuration. This is the most common one is that we usually said this is called the 4+1. 4+1 means you have a quadcopter. The quadcopter you have 4 rotor plus one push propeller, okay? Push or pull propeller. This propeller is for the cruise mode, and this 4 rotor for the takeoff and landing, okay? So the most dangerous or sensitive situation of this kind of drone is for the transition stage. For the transition stage that you pull your drone to a certain height or altitude, and then you have to have the transition to the cruise mode. That is the most weak point for such kind of drone, because at that moment you have not enough speed for the fixed wing, and you have very low resistant capability for the gust wind or any disturbance. So this kind of configuration is very more feasible for the cost, but the performance right now is not so good for gust wind rejection. Okay, so the other two is tail wind or tail rotor. Tail wind, tail rotor has better gust wind rejection. Okay, and this one for the typical classification we call LTA. LTA means that certain special gas like hydrogen or helium is filled in, and you have a lower density with respect to the air, and you have the buoyant force, and also you are with the propeller, so you can manipulate the position of such kind of we said balloon or the ship, right? The fly ship. Okay. So at the beginning of our project, we just started from 2017 also. Okay. At that moment, the DJI has the photo taking consumer drone, and also at that year, they just begin their business for agricultural drone. So they shift from the consumer product to commercial one for agricultural application. And right now they are growing more significant in this field. So they have T40 right now. And the next year they will have T50. So they can carry 40 liter or 50 liter for chemical spray. So this utility drone is the right transition for their business. Okay. And also in the past, we have already decades of development of the military drone, like Taiwan. These years are very eager to acquire such kind of drone from the United States or other countries. And also in Taiwan, also we have our own long endurance, this kind of bigger, this kind of, we said male level. The male level drone, usually we have the wingspan up to 20 meter. Okay, the 20 meter drone, usually you have at least 6 hours or even 16 or 20 hours or more than 24 hours endurance in the air. Okay, and the United States in the past 3 or 4 years, they are promoting their military helicopter drone to Taiwan, but the Defense Department resigned in the final stage because they said that it's very, it costs very much to maintain this product, and also this is an old version. And they right now have a newer version of this of the helicopter drone for military application. So for this version, about 20 years ago, developed for the ships or spatial missions. So right now, it will cost very much to maintain and operate. Okay, and also there are very booming topic in the personnel mobility application for the drone. Okay, many people noticed that many automobile makers like Toyota or Hyundai, Kia, and also GM, okay, and the Ford, they are investing such kind of new business. Like Hyundai is investing the volocopter from Germany in their country. And also mainland China is also inviting volocopter to mainland China to help their production line. Okay, so the personnel carry drone right now is a new business and booming right now. More than 100 startups worldwide. Okay, and the most famous project is the air taxi project from Uber, right? And also other countries, other companies also, they are trying to build their air taxis experimental project. So, as I said, we are trying to develop the high payload and endurance utility drone. So how to evaluate your payload and endurance performance of your drone? And right now, you can have such kind of calculation that you multiply these factors together, the overall maximum takeoff weight, and your endurance time in the air, and also your working range together. And intuitively, you can have such kind of distribution. The more expensive drone, then you can have a better performance index. So this region, the purple region, is our interested target about the drone cost and its performance. Okay. Something like that. We have to develop 3 years ago. We need to satisfy the payload more than 30 kilogram and the endurance more than 45 minutes, and the working range more than 15 kilometers. This is the expectation from some government institute for some delivery service. Okay. So right now we would like to. I will begin to talk something about the system integration procedure of this kind of drone. Okay. So something like this historic development path, like in the beginning you have to acquire your propulsion module, your electric propulsion module, and also your power source, and then you have to design your fuselage together with the control system. Then you will have the overall drone with some special functional payload. Okay. So in 2020 and 2021, we have the drone with payload more than 30 kilogram and even 50 kilogram right now. So in ITRI, including several core labs, like my lab, mechanical and electronic system, and also our ICL, information and communication lab. We together developed several core technology, like the power system from our lab, fuselage design from our lab, and also the navigation and the remote system from the ICL, and we together to build a longer range teleoperated drone with 4G communication, and also right now with 5G. And in the coming future, we will adapt the low altitude satellite. And right now we are enhance our AI function. Okay. So these are some samples or experience of our project, like for agriculture application here in Taiwan, and also some for some communication relay, and also for some safety control, and for delivery. Okay, and we